Good morning, I can't even talk. Good morning, Precalculus scholars. I decided to make my video early this morning just because on campus is down. So I'm like, hey, what better to do? Make a video of my lesson for Wednesday. Guys, I just want you to know I've been praying for you a couple things. I'm praying for maturity. I'm praying that you guys learn self-discipline. I pray that you get rest. And I'm noticing some of you doing your homeworks really late at night. That's not called rest. That's called procrastination. So let's try to get those done as much as possible. All right, so today we're continuing with conics. So remember we did circles first, right? And circles have the standard form of x minus h squared plus the quantity y minus k squared equals the radius squared, where your center is h and k, and your radius is the square root of whatever our number is at the end, and it's always going to be a positive value. And then we talked about parabolas, and I know parabolas have been really difficult for you guys, and it normally is. So don't feel like it's any different just because you're you're doing e-learning, but it's the same idea. But remember, parabolas can open up or down, and so we'd have the standard form y equals 1 over 4c times the quantity x minus h squared plus k, or they can open sideways, and that's going to be x equals 1 over 4c times quantity y minus k squared plus h. So notice h and k switch spots. But today we're getting ellipses, okay? And the cool thing is with an ellipse, it's like that oval. So it's not a circle, but it's not like a parabola. There's some really cool things. Now, the definition of ellipse is the following. It's the set of all points such that the sum of the distances from P, which is a point, to two fixed points, the foci. So think of this like a string, and that it's attached to the two focal points. And this distance right here, these two segments will never ever change. So when I say never ever change, they change kind of locations, but they're linked together pretty simple, and they all work, and it will never change. And I'll give you a video in a little bit about how that all works. Okay, so there is a standard form of an ellipse. It is very similar to a circle, but it's not, okay? It's the following. It's x minus h squared over a squared plus the quantity y minus k squared over b squared is equal to 1. Okay, so notice it's kind of like the equation of a circle. Your center is going to be at h. Okay, so this would be your center. It's the half right where your two axes, which we're going to talk about in a moment, intersect. Here's the other thing, though. It can be written like the following. X minus h over b squared plus y minus k squared over a squared is equal to 1. Notice that a squared and the b squared change, okay? A squared is always the largest, and that is going to determine how the long part of your ellipse goes. It's which way is it opening. So here's what I mean. All right, if a squared is underneath the x, your ellipse, so we're going to go a squared under, and a squared is the bigger one, under x. You are going to have an ellipse that goes this direction. And yes, my ellipses are so bad, okay? And this would be your foci, and it would be going this way. So if a squared under x is bigger, okay, so a squared is bigger, you're going to go long ways horizontally. But if a squared is under your y value, your I can't even talk today, ellipse goes this way. So the long way goes vertically. All right, so there's some terms that you need to know. Okay, the midpoint between the foci, and so going back here, it's called the center. So let me show you where that is. This is going to be your center. All right, so it's always going to be halfway, and that is always your h and k. The line segment through the foci, so this segment we're talking about right here, with the endpoints on the ellipse, is called the major axis, okay? It's basically, when we say it's major, it lets us know it's the longest one. of those, okay? Now, we also have what's called the minor axis. Now, the minor axis would be going this way. So let me show you on the big one here. Your major axis goes from here to here. This line segment is your major. Your minor on this one up here would be this value, your minor axis. So that helps us determine actually how to draw it. So it's very helpful, quick information to work with. The endpoints of the major axis are called the vertices. So we're still going to use, when we work with this, the vertices. Sound familiar, right? So here would be your vertice here, and you'd have another vertice right there. All right, so the line segment through the center and perpendicular to the major axis, notice perpendicular means right angle, with the endpoints on the ellipse is called the minor axis, and that's what I already showed you. It's the one going from here to here. Okay, so with the minor axis, it also has endpoints. Notice they're right here and here. Okay, those are called the co-vertices. So I'm just going to label them CV, CV. All right, your co-vertices are just the endpoints of your minor axis. Now, we are going to still use a C value. The C value helps us figure out where the focus goes. Now, let me show you a couple things up here. If you notice, do you notice with the major axis here, we have a distance of A and we have a distance of negative A. Those helps determine where the vertices are located. Notice with your minor axis, we're using B to figure out the distance of when we're working with those. So you go B distance either up, down, right, left, whatever direction your minor axis is when you're working with it. But we need C right here to figure out the foci. All right, so we have to figure out those 2 points using C, and we use the following equation. Be careful, because let me close this. Here we go. It is the following: C squared equals A squared minus B squared. Now, I have a little bit of a video, and this might not run well, that shows you how to draw a perfect ellipse. So let's see if we can watch it here together and see if it's going to work. You notice the 2 toothpicks are going to be your foci, and the string is going to be your value C, the consistence point. So here we go. Yay! I mean, your lives have been forever changed after that video, but that kind of shows you the idea of working with it. Now, we're not going to be quite that awesome. All right, let's see if we can get the work on this one. All right, so what is going to be the key? Well, our ellipses are not always going to be in standard form. So the key is we're going to use completing the square. And we'll go from there. You also have to understand common denominators and making sure how things work. All right, so we're going to find here the center, the vertices, the foci. Now, we're not going to do co-vertices. We're just going to do vertices, but we're not going to do eccentricity. What is eccentricity? That is like how close to a circle, how elliptical is this? It's used in astronomy. It talks about the orbit of the sun and things, so you do not have to worry about the eccentricity in this case. But here is the equation that they give us. Notice it's 9x squared plus 4y squared equals 36. Standard form tells us we have to have it equal to 1. So how do we change that? Well, the cool thing is to change it to standard form, you have to divide by 36. And when we do that, we get x squared all over 4 plus we get y squared all over 9 is equal to 1. Now, you need to pick out your A, B, and C values. Remember, A squared is always the largest, so it's here underneath 9, okay? So we know A is going to be the square root of 9, which is 3. Because remember, standard form, let's go back to where our standard form is we're actually using this one this time. We have our A, B, and C are squared in there down below. Okay, so A is 3. That means that B, so the square root of 4, is 2. We have our center. Actually, let's wait for a moment. Let's find our C. So we got to do C squared, which is going to be A squared minus B squared. So we got 9 minus 4. So C squared is equal to 5. C is going to be the square root of 5. Yes, there's a plus or minus there, but remember we're describing it with the positive. So square root of 5. And we can use that to solve for all of our information. First of all, what is our center if I do not have any values with the x squared and y squared? Well, our center is at 0, 0. It's at the origin. So here's our center. Now, how do we find the vertices? Well, the vertices, the easiest way to do this is use the fact that our major axis, from the center point, we will add A or subtract A from that point. And we know from looking at our graph, since A squared is underneath the y, we're going to stretch this way. So we're going to go up A, so 1, 2, 3. There's a vertex, and we're going to go down 3. So my vertices are here at 0, 3, and 0, negative 3. Now, our foci is between the vertices and the center, okay? So it's going to be on the inside, okay? So to get your foci, we have to use C. And C, we're going to add or subtract as well. Now, what's the square root of 5? Well, that's 2.2 something, okay? Because square root of 4 is 2. So understand it's a little bit bigger. So our foci is going to be somewhere like right in here and like right in here. Okay, but we just take what C is and we add it. Let's see if this is not giving me a good clear thing. We add here and we subtract it down here to get the foci. So we're going to get 0 root 5 and we're going to get 0 negative root 5. Now, how do I graph this quickly? Well, I'm going to use my co-vertices, my minor axis. So B is the easiest way of doing this. You just go over to the left and to the right of your center, and then I connect my vertices and co-vertices, and I have a beautiful parabola. Ellipse. Why do I keep saying a parabola? I think I said parabola so many times the last few days. I messed it up. Excuse me. A beautiful ellipse. All right. Now let's see if we can do this with some of our other ones. Okay, we're going to do the same thing. It says find the center, vertices, and foci of the ellipse given by the following. We get 5 times the quantity x minus 3 squared plus 25 times the quantity y plus 2 squared equals 25. All right, so with this, again, it's not in standard form unless it's equal to 1. So we're going to divide everything by 25. So we get x minus 3 squared all over 5. Plus y plus 2 squared, that's going to be over 1 because 25 over 25 is 1, equals 1. So this is standard form of the ellipse. Now, a squared is this time underneath x, so we know our ellipse is going to be going, its major axis, it's going to be stretching out horizontally. How do I know this? Because of where a squared is located. So with this, my friend, we actually have to do some calculations, okay? We have to find our A, B, and C. All right, so our A is the square root of 5, okay? So with that, remember, that's approximately like 2.2-ish, so we're okay. Then our B is the square root of 1, which is 1. All right, our center of this circle is going to help us out. We have to know that is our H and our K here. It's going to be at 3, negative 2. So I go 3, negative 2 is our center. Now, we have to use our A to be able to get us our vertices, okay? So we're going the long way this time. All right, so let's use green. All right, so to get our vertices, we go horizontally. So we go over 2. So it's going to be like right here, go about 2, 2.5, but those would be your 2 vertices. So how do we do this? We added or subtracted that to my x value because we moved horizontally. So your vertices are going to be 3 plus root 5, negative 2, and 3 minus root 5, negative 2. All right, now we have to get our foci. Well, to do that, you have to find, let me see if I can get this to work here. We're going to have to find c. So to do that, we go, no, c squared equals a squared minus b squared. So that is going to be 5 minus 1. So c squared equals 4. C is going to end up being plus or minus square root of 4, which is, and remember, we used the positive with this, 2. So we are going to move from my center 2 to the right and 2 to the left. Okay, and the reason why we do it like that is because remember, everything's still based off of our center, and we're moving the foci and the vertices have to be on the major axis. So what are we doing here? We're going to go, see if it's going to write for me. Go by 3. It totally moved too much on me. Do not know why it did that. Here we go. We're going to go 3 minus 2, negative 2. What does that give us? That's 1, negative 2. And then we're going to have here, so that's one of our foci, and then we're going to have 3 plus 2 minus 2, and that's because our y's don't change. And that's 5, negative 2. So those are our 2 foci. All right, now we just have to do a quick graph, which means we have to know our minor axis, so we get our co-vertices. We know B is 1, so we just have to go up 1 and down 1 to get our co-vertices, and then we connect our vertices and our co-vertices, and we get that lovely ellipse, which is drawn horribly on my part, but we got it down pretty good. All right, let's look at the next one. It says, find the standard form of the equation of an ellipse centered at the origin. Okay, so the origin is at 0, 0, which means we now know h and k, right? They're both 0 and 0. With a major axis length of 10. Now, if they give you the major axis length, the length of it is twice the value of a. So our a is actually going to be 5. And then they say the foci is at negative 3, 0, and 3, 0. So here's what we need to do. We need to do a quick graph so we understand where everything is located. So the center is at 0, 0. Okay, we're going to put the foci in, and they tell us that's at negative 3. There's one focus, 0, and then at 3, 0. Another focus. Now remember, the focus is going to give you the value of C. And notice where that's going. It's going horizontally. So that means we have our major axis is going to be horizontal. So we're going to be using this form. X minus h squared over a squared plus y minus k squared over b squared is equal to 1. So huge that we have this. All right, so I'm going to plug in what I know so far. So I got x minus 0 squared over, well, what do we know a is? Because our major axis, the length is half of that. And so that's going to be 5 squared. And then we got plus, I get y minus 0 squared. I don't know b squared yet, but I can use what I know to help me with this. All right, so with this, my friends, we are going to sit there and we're going to put our vertex in. The distance is a, so I go from my center and I got to go 5 over. So vertex right here. But the thing is, I need to know b. Well, to do that, we're going to use our lovely little equation, okay? We're going to use the fact that c squared equals a squared minus b squared. Okay, so what do we have here? C, we know, is a distance of 3 because we go from the center to the foci, we went 3 times. So that's 3 squared. A we found to be 5 because that's half the length of your major axis, okay? So we're going to go 5 squared minus b squared. So I get 9 equals 25 minus b squared. I get a negative 16 equals negative b squared. B squared equals 16. The square root of that would be 4. So what is going to be b squared? Well, that is going to be, well, 4 squared. Now let's finish simplifying this, okay? So I get x squared all over 25 plus y squared all over 16 is equal to 1. Now, how do I graph this real quick? Well, my friends, we know that b is 4, so we just got to go up 4 from the center and down 4 from the center. And then we just have to draw in as much as possible our ellipse. That is horrible on my part, but hey, I can laugh at myself. Okay, now the next part, you need to be really careful, but we're going to use completing the square. Now, we're not going to graph it this time, but we're just going to change it into the form. You should still be able to pull out the center. You should still be able to know what the major and minor axis, your A, B, and C are from this information. But I want you to notice this. It looks nasty. Okay? Normally we say when we're working it, we know we're going to use completing the square. We're like, hey, let's divide everything. So we have x squared, y squared in front is 1, but don't do that. Right now, the first thing I need for you guys to do is to group your x and y's together and to move your constant over. So here is what we're going to do. We're going to do it right here. So we're going to go 25 x squared minus 200x, and we're going to go plus 9y squared plus 36y is equal to a negative 211. So now we're going to have to do completing the square. We're going to use a little bit of process here. First of all, I do not want a 25, so we got to look at this one in front of the x squared. So I have to factor out 25 from those two terms. So I get 25 times the quantity x squared minus 8x, and then I'm going to go plus blank because I'm going to be working with the fact that we're adding it on. And then we're going to go plus 9, factor out a 9, because we get y squared plus 4y plus blank. And we're going to get a negative 211 plus blank, because we're going to have to add it onto both sides. Okay, so what do we do next? Now we're going to do completing the square inside the parentheses still. All right, so what is a negative 8 divided by 2? So we're going to take negative 8 and we're going to divide it by 2. That's a negative 4. What's a negative 4? Negative 4 squared is going to be 16, right? I don't know why that's not a plus sign there. So we put 16 here. But we have to go, when we're adding to the right, we're really multiplying this 25 to that 16. So what's 25 times 16? And that's going to end up being 400. So I actually add a 400 over. Then I'm going to do completing the square for the y's. So I take the 4 and divide by 2, which is a positive 2, and we square it, which is 4. But I'm really adding on a 36 the other side. So I got to go 9 times 4, which is going to give us 36. So then we're going to rewrite things. So I got 25 times the quantity, and this is where we got our square. We go x minus 4 squared plus 9 times the quantity y plus 2 squared equals, and we added everything over here on the right, and that's going to be 225. All right, we are almost in standard form, okay? To do that, remember, it has to equal 1. So what we're going to do is we're going to divide everything by 225. And when we do that, we get the following. The quantity x minus 4 squared over 9 plus y plus 2 squared all over 25 is equal to 1. So this is standard form for my ellipse. Notice plus. Here's a few things. Let's see if we can answer these even though I didn't ask you when you're doing this. Okay, so here's the thing. You have to, in this case, remember where your center is. Our center is at h and k. So it is going to be at 4, -2. I notice that a squared is below the y, so I know I'm stretching it this way. So here'd be my center at 4, -2, but I'm going this direction, so I'm actually adding on to the y. My foci for this would be going up or down from 4, -2. I'm going to go up a, which is, by the way, a squared is 25, so a would be 5. So I'm going to go up 5. And what do we get here? If we go up 5, I'm going to get 4, 5. And if I go down 5, I'm going to get 4, -7. Someone goes, where did I get that? Remember, all I did was graph. I know my center is at 4, -2. And then I'm going to do what my A says, because I know it's going to be up 5 or down 5. I go up 5, so 1, 2, 3, 4, 5. We go down 5, 1, 2, 3, 4, 5. And those would be my 2 vertices using A. I shouldn't call that foci. Oh, my friends, I didn't use the foci. What did I actually use? I used the vertices. Sorry. Let's put that vertices on here. Okay, to get the foci for this, we're going to have to use C, okay? And so we know the foci is somewhere in here. So to get C, we're going to have to use our formula. C squared equals A squared minus B squared. So C squared here would be 25 minus 9. So C squared is 16. C would be 4. So I'm going to go up 4 from my center. There's our focus, and we're going to go down 4 from my center, and that is going to be our other focus. So we're using our values, so we're going to get here, we're going to get 4, and it's going to be -2 plus 4, and we're going to get 4, -2 minus 4. What are our 2 vertices? So 4, 2, and 4, -6. All right, now, with this, we want to be able to graph this quick. Only thing missing is my co-vertices. Well, remember we use B in order to get that. Well, what's B in this case? Well, B is just going to be square root of 9, which is 3. So I just go over 3. 1, 2, 3. We go over 3 the other direction. And we could draw in our ellipse. Now, you are not required to do all of that, but that is the type of information you'd have to be able to do on your homework. Guys, here's the other thing. Google. Use YouTube videos from other teachers if this is hard to understand. But also remember that we are going to be meeting every class period. It is in your assignment when our Zoom meeting time is. It is going to be critical for you to join this and ask good questions. On Friday, I haven't decided if we're going to do a test or a review day. I mean, a quiz or not a test. A quiz. So make sure you're on top of this, my friends. Thank you for your patience with this videos. I know they're a little bit choppy, but hopefully they're helping you get what you need.